So welcome to our webinar on our StreamWatch program and general stream health and how we monitor those things. My name is Steve Tuerto. I am the Director of Science and Stewardship at the Watershed Institute. And today our webinar will be given by Erin Stritz, the Assistant Director of Science and Stewardship at the Watershed Institute. Erin has been with the Watershed Institute for going on 9 years. So she's our resident pro. She has worked very hard to build the water quality monitoring program and many other things within the organization, and is currently leading a program called the Watershed Watch Network, which is a collaboration between the Watershed Institute and the New Jersey DEP to create a network of organizations, of like-minded organizations, to increase the capacity for volunteer programs to monitor water quality throughout New Jersey. A little bit about the setup for our for the webinar in general. Erin will be the only one speaking. Everyone else will be on mute. There is a Q&A box at the bottom of your screen, or at least there should be. So if you have any questions, please post them in the Q&A box. And I believe Erin will take a moment in between sections of her talk. We'll take a brief moment to address some of those questions. And then we will move on. I believe also there will be at least two polls that Erin will post, which is an interactive component of the webinar. And you can it's pretty self-explanatory. Question will be posted and you can place your answer. And with that, I'll turn it over to Erin.
Okay. Thank you, Steve. And thank you, everyone, for joining us this afternoon. We've had a few fits and starts with these StreamWatch webinars, so I just want to thank you so much for your patience. Our StreamWatch program coordinator has had to go out on medical leave, so I am filling in, and we are keeping Nick Hansen in our thoughts, as we are all of you. I hope that you are joining us safe and healthy and from your home. I am today joining you from the Watershed Center's Water Quality Lab. The facility is closed to the public. Staff are still working from home, but as you could see if you joined a little bit early, we have some live lab demonstrations that I wanted to be able to show to you. And I don't have a digital microscope in my house, so I figured I'd pop in for a few hours today. First, I want to start just by going over what we have planned. I'll go into an introduction about the StreamWatch program, where we work, who our volunteers are. We'll review the 3 different monitoring teams, which is a great introduction if you are looking to get involved for the first time, or if you are a current member of one of the teams and would like to learn more about the other teams. I have 3 different lab demos set up here that I will show you as we go along. Then we'll talk about what we do with our data, and then hopefully by the end, you're gonna wanna get involved. So as Steve mentioned, please feel free to use the Q&A box as we go to ask questions along the way. And I will pause every so often to just check that box and see if there's any questions. So first, the Watershed Institute is an organization that has been around for a while. Our goal is to protect clean water in central New Jersey. We do that primarily first through conservation. Here, I'm joining you from our Watershed Reserve. We have about 1,000 acres. The trails are still open, so you're welcome to come as long as you're practicing social distancing guidelines and bring a mask with you. Our property that we preserve, it helps to protect clean water by making sure that we do have natural spaces that will be retained in central New Jersey, especially, you know, as development started to increase after the Industrial Revolution. We use our property here for education. That's a great way to get people to fall in love with their environment. We bring children out here, school groups, adults, or we would in a normal year. And we try to engage people with the property here, our forests, our meadows, the Stony Brook, which flows through the property. And we really hope to be able to bring you all back soon. We also have our advocacy team that works, it's kind of an extension of education. They provide municipal guidance based on our scientific practices to help guide local decision makers into making stronger environmental regulations. They work both at the municipal and at the state level. And all of this work, of course, is supported by our science programs, one of them being the StreamWatch program. We hope that science kind of finds its way back through what we do at a policy level, what we teach in our education programs, and then also how we steward our reserve here as well. But the organization started back in 1949 just by a group of local concerned citizens who had noticed that agriculture was really spreading. It is the Garden State here in New Jersey. And they were noticing increasing amounts of soil erosion, which was then causing sedimentation in local streams. So they gathered together with that goal in mind to try to figure out how to protect stream health, really from an agricultural perspective. The focus of that was, of course, the Stony Brook Millstone watershed, which is outlined here in orange. That's was our initial focus area here in central New Jersey. And of course, we have expanded our focus over the past few years, well, over the past decades. And there were some pressing questions that have led us to keep growing in what we do here. One of the questions was, are our streams healthy? So there was kind of this like anecdotal evidence back in the day saying, okay, agriculture was impacting water, but you know, how do we actually know that? We have to figure that out. But if the streams are not healthy, figuring out how they are impacted and to what degree they are impacted is really important in being able to figure out what we can do to fix it from there. And then also a big component to watershed education, to watershed health, to stream health is how do we get people to care about it in the first place? And this is really the primary place from which we approach a lot of our work is, you know, we're out there monitoring. How do we get people to care about the results of that data that we're collecting? One of the best ways to do that is to get people involved in the actual data collection. And so that was when, in 1992, the StreamWatch program was founded. You can see we have this cutout from our Wellspring newsletter in that old-timey font that the StreamWatch program was launched initially with our chemical action team. And then through the years, it expanded to cover more and more facets of stream health, and it's grown to where it is today. Our three current teams of StreamWatch are the chemical action team, the biological action team, and the bacterial action team. So we came up with really cute animal names for the first two. We had a little struggle with the BACT team, but it's accurate, right? Each of these teams has its own focus, its own different protocols, its own way of collecting data, its own frequency of collecting data. And so I will share a little bit about that with you guys to hopefully get you interested in participating. The Chemical Action Team, or our CAT volunteers, they go out monthly. They have an assigned site. We give them a kit. They monitor these parameters. These are kind of the basic water quality parameters that you really want to know when you want to take the pulse of your stream, really figure out stream health. This is what you want to look at. pH, dissolved oxygen, nutrients, nitrate and phosphate, turbidity, and water temperature. Now, our biological action team, they go out 3 times a year. So it's less frequent, but each visit is more intensive. So they're spending more time out in the fields. They're spending time in the lab, processing their samples. And what they are looking at is benthic macroinvertebrates. Do you know what benthic macroinvertebrates are? We'll get into that in a second. And our bacterial action team, they go out every week during the warmer months, and they will sample for E. coli, bring those samples back to the lab where we will analyze those samples and try to figure out how much bacterial contamination there is in the water. So I am seeing a question here from Louis. It says, please define healthy. And healthy for what human use? Do you mean, for example, healthy enough to use as drinking water, or just healthy enough to not to cause issues to people who might get into the water? This is a really great question. And it's something I think that when we get into water monitoring, we kind of forget these terms that we use: healthy, integrated, impaired. When we're looking at the health of a stream, a healthy stream supports multiple uses. We have animals living in the stream. We have an entire aquatic ecosystem that really depends on water quality to be able to survive. If you're a fish, you need dissolved oxygen in the water to be able to thrive in that ecosystem. So biological health is definitely one aspect of defining a healthy stream. Another part of that is, of course, the human uses. If we are going swimming in Carnegie Lake, we want to make sure that we don't have enough E. coli or bacterial contamination that would get us sick if we were to recreate in that water. There's also different uses that people monitor for in regard to source water for drinking water, source water for agricultural watering. The list goes on, So when I'm talking about a healthy stream, it's kind of a holistic view of the stream, probably with a focus on the actual biological health of the stream. So thank you for that question. All right, we have over 27 years of data. We started in 1992, collecting chemical data every month. We have over 40 sites across our region, and this is a peek at what our region is. We have this Stony Brook Millstone watershed, which was the original focus back when I showed that map. And we have recently expanded to include a focus in the Delaware River Basin. So Jacobs Creek, Assunpink Creek, Shippatocking Creek, all of these streams were kind of close to our home base, but flowing in the opposite direction into the Delaware River. So we decided we should probably include our monitoring work in those areas as well. So this is kind of the inset of where we are in the state of New Jersey. This is the outline of the original Millstone Basin and where our 40 sites were located. Now, when we were choosing these sites, it was important to us that the sites were representative of the watersheds that they covered. So a lot of times we will place the monitoring sites kind of at the outflow of a particular watershed to try to capture what's going on upstream of that. We do obviously have limited resources. We have limited equipment. We have limited volunteers in some cases. So we really have to be strategic in how we place our monitoring sites. Of course, when we're selecting our sites, we also want to make sure that our volunteers going out to these sites are staying safe. So making sure that there's safe parking and a safe trip down to the stream. We're not, tumbling down any mountains to get down into a stream. And then also we have to get permission. So all of these sites, they may be placed perfectly from like a scientific point of view, but we need to make sure that the person who owns that property is going to let us access that stream. Some of this is on public land in state or county parks, but some of these are just behind someone's house who was willing to allow our volunteers to monitor their stream. Now, this is what the StreamWatch program will look like once we finally fully expand into that new section of the Delaware River Basin. So we would grow from 40 chemical sites to 75 chemical sites. 35, about half of those would be biological sites, half would be bacterial sites as well. And this is something that we are trying to get into. Of course, as I mentioned, there are constraints on our resources. So we, again, have to be strategic about where we expand into. So I'm seeing another question here from Lakshmi. Is it possible to test for chemicals such as PFAS, hexavalent chromium, and other chemical contaminants that are not listed by EPA? Great question. With the StreamWatch program, what we are monitoring for are those kind of basic parameters that just give an indication about general stream health, looking at those dissolved oxygen, pH, temperature, macroinvertebrates, and bacteria. There is certainly a whole huge wide world of the different options that you could monitor your streams for, two of which would definitely be hex, chrome, and PFAS. Those are particularly important when you're looking at drinking water quality. We don't have the facilities to test for those chemicals here, but I would say that it's pretty important to test for these chemicals if you're getting your drinking water from a specific source. So if you have a well, this would be a great thing to test for. They definitely test for them for these parameters for public water systems as well. So it's definitely possible. You should do it if you're drinking that water. And hopefully when things start opening back up, we'll be able to relaunch our TapWatch drinking water program that will provide a vehicle for you to come in, get your water tested for these contaminants specifically. Okay. Moving on. So who is out there monitoring our streams? We have 40 sites. We obviously need a lot of people to be out there actually doing the work in the field. And we do. We have a diverse group of volunteers that have given their time to go out into the stream and send us the data. Here are a few examples. We have Tom Smith. He's a science educator from Heightstown. He's been monitoring for going on 15, maybe 20 years now. Doug Lishik down in the Millstone Township from the Environmental Commission. Their whole Environmental Commission, they get together and they monitor the Millstone River at its headwaters, which is super valuable information for us. Sonia Michalak, future Nobel laureate, that's a fact. She's started with us when she was about 8 years old and is now graduating from high school this year and has volunteered with the StreamWatch program that whole time. And she has a bright future ahead of her. We're very proud of her. Patty Maslanka, a veterinarian in Rocky, somewhere in the watershed. But she, has basically taken these StreamWatch principles into her life and actually started to institute river-friendly practices at her veterinarian practice as well. And then we have Jonathan Allen. He's a retired physicist. He's another volunteer that has been with us for a number of years, and he's someone who can take his history, his past, being a physicist, and he's actually created a number of inventions for the StreamWatch program. A way to take a water sample without dunking your hand if it's really cold. A way to stir up a turbidity sample by, having a rod and this like automatic spinner. We have a number of really excellent people working with the StreamWatch program. And to join it, you really need to be dedicated. We do ask for a 1-year minimum commitment from our volunteers. But you can see from this chart that many of our volunteers have exceeded that 1-year minimum requirement. About half of the volunteers that we've had ever in the program have been with us for 5 years or more. And those that leave under 4 years are usually those that are graduating from high school and they are going to college. And of course, we want them to go to college. They don't have to stick around and monitor water. And in a lot of cases, they will actually pass down their StreamWatch site to a younger sibling that's coming up in 9th grade, or to a friend in school that will then continue to monitor that site for them. So we love our volunteers, of course. Okay, I'm going to pause temporarily and see if we have any questions. So Joan asks, who creates your attribute tables so we can have fields if volunteers have access to additional chemical, bio, or bacterial tests? Interesting. So what Joan is saying is, if you are a current StreamWatch volunteer and you have access to meters or to a lab and you want to collect more data, how can you do that? I think that's what you're asking, Joan. So with all of our data sheets, we have comment fields where you're able to, any other thing that you're doing out in the field. I've had volunteers that submit the barometric pressure every time they go out because they love weather data. We have volunteers that are really bird nerds and will write down every single bird that they see while they're out there sampling. So there's definitely options to submit that information. I should say, though, that our programs are supported by quality assurance project plans that are submitted to and approved by DEP. What that means is we are defining exactly how our data is collected so that they can feel comfortable using it for their own uses. So with these additional types of tests, they may not be used kind of at that level, but it's still really valuable information to get. Okay, let's see. Steve, we have other questions? Oh, we do, okay. Are the results of your testing being posted regularly in a publicly viewable internet location? Yes, I will be getting into that a little bit later in this presentation, so we're gonna put that question on hold for now. And another question, I have a stream by my house. Would I be able to test a stream if it's not currently being tested? That is a great question. I think that in that specific case, we would want you to contact us. Our contact information will be at the end of this presentation, and we'll be able to connect with you and see if that stream kind of fits into our guidelines for site selection. And another question, do you regularly submit results of your testing to governmental agencies and other NGOs? Yes, yes, we do. We submit our data through the EPA's Water Quality Exchange. It's an online database. Our data is submitted through there so that it's viewable by anyone. You can Google Water Quality Portal, and that is basically a one-stop shop for water quality information. You can go there, look at data from the Watershed Institute, from DEP, from Raritan Headwaters, from Musconetcong Watershed Association, all the different groups that are submitting their data into this one place. And I will have a little bit of, more information about that in a minute. So Steve, can you please activate the first poll? We got a look at the locations, our monitoring locations. And what I wanted to know, you could be joining us from Alaska. That's kind of the beautiful thing about webinars, right? So I want to know, in your area, what do you believe to be the greatest threat to stream health in your region? Here in central New Jersey, that could be something entirely different. Or just because of our experiences, we believe something else to be a larger threat. So I'll give you a second to answer that question. And then Steve, when the answers stop coming in, can you publish those results?
Numbers are still bouncing around a little bit.
Okay.
I'll give us 15
It's
more seconds.
not an easy question, so.
All right, going to end the poll now.
Okay. Impervious cover, definitely. Yeah, so I tried to include a list of all of the major issues really facing our streams. Impervious cover is kind of the biggie, right? It seems like about half of the participants chose that as the greatest threat to stream health. I would agree, that's what I chose as well. So impervious cover, basically what that is urban development. Paving over natural surfaces so that the roads will not allow for natural stormwater to infiltrate into the ground. What that does is creates this overland flow where the stormwater will pick up soil, like the soil erosion they were worried about in 1949. Maybe it will pick up pesticides or fertilizers from your lawn or from an agricultural area. It'll pick up litter, and take all of these things into the stream where they will negatively impact water quality. So thank you for participating in that. If there's something else that really concerns you, feel free to write that in the comments. So now we will look at each of the 3 StreamWatch teams. But first, I just wanted to introduce kind of the 3 different major ways that we conduct stream assessments. And that is with a visual or a physical assessment where you go out, you look at the stream, maybe you take some depth, some width measurements. On the other side of that, you could do a chemical monitoring or bacterial monitoring. And what that is, it's really a snapshot in time. When you take a dissolved oxygen test here at 12:30 on the Stony Brook, it's going to be different at 1:30 and at 2:30. These are values that are constantly changing. So what we're looking at really is kind of average and baseline and trend values for that kind of thing. But if there was a chemical issue where, say, this influx of phosphorus is getting into your stream and you don't capture that chemical data right at that moment that contamination is happening, you're going to miss it if you're just doing chemical monitoring. So biological monitoring is really the type that brings all of this stuff together. What we're looking at here is who is living in the stream and are they surviving? Are they thriving? And I'll get into that in a few minutes. So we'll start with the chemical action team. And this team monitors water chemistry every single month. There is an assigned weekend where the volunteers will go out to their assigned site. It's kind of an independent activity. We have chemical kits. They look like little briefcases. You can see in this photo, This volunteer has created a nice little setup. Maybe it's a rainy day, so they brought out a chair and a table and set up an umbrella. Especially those volunteers that are going out for 20 years or more, you start to really develop a routine. So they take that kit out, you do the tests right in the field. And when you start getting more comfortable with that monitoring work, it takes about an hour to work through a full sample. So again, these are the different parameters that we're looking at. All of these are impacting the biological health of the stream. We want to make sure that the conditions are right for the native species in that ecosystem to survive. So what I wanted to do here is to offer kind of an introduction into the way that we actually do our testing. So here, I have color comparators from Lamont. This is what we actually use in our test kits. And in here, you can see this. I have 10 milliliters of stream water that I collected from Beeden Brook this morning. And basically what I will do is I will put this wide range indicator, 10 drops, into our test tube. Now what that does is this has phenolphthalein, which produces a color changing reaction, which will then tell us pretty closely what the actual pH of that water is. So I just want to put this behind it so you can see. You can see it kind of goes from the lower range. So here we have a 3.0 to a 6.5 range. This is in the more acidic range. It goes from red into orange into a yellow. And then on the higher range, when you're getting into the more alkaline range of values, we start getting into greens and blues and purples. So that's from 7.0 up to 10.0. So let's see how Beeden Brook is doing. I'm gonna take my wide range indicator. One, two, three, four, five, 6, 7, 8, 9, 10. Wonderful. Now you can see it's kind of turning green a little bit. Let's mix it up. Can you see that? I'm gonna put a white background behind that. So here we've got kind of a, maybe on the yellow side of green. This was our color reaction. So I'm going to pop this into our more alkaline tube. That might be, I don't know. Is that 7.0? What do you think? Let's check the lower range. It's definitely more green than that 6.5. So here, I think I would say that this value taken this morning from Beeden Brook is a 7.0. And that's right in the middle of the range that we're looking at for a healthy pH value in our streams. So that's good news for Beeden Brook. So at this point, I think we have a few questions. I'm just gonna pause and check in here. Okay, are there tiered levels of water quality testing? There used to be in New Jersey a tiered data quality system, 4 tiers that all community monitoring groups like StreamWatch would be defined by. Tier A was environmental education. Tier B and C were kind of community stewardship and municipal education. And Tier D was the most stringent type of monitoring work that would be used to submit your data to DEP for their use for regulatory purposes. There is a new tiered system now. Now it is 3 tiers: educational, targeting, and regulatory. So the StreamWatch program actually falls kind of in both tier 2 and 3, depending on the type of team that you're looking at. So we do that kind of allows us to submit our data to DEP. Being at tier 3, that data moves on and is then used for regulatory purposes. Okay. Do you have a team that focuses on the Stony Brook? Yes, we have, I believe, 5 different sites on the Stony Brook that go from the headwaters down to where it meets with the Millstone River at Lake Carnegie. If you are living along the Stony Brook and you would like to get involved and start monitoring in your area, again, please contact us and we will check to see kind of what's available. At some points, we have a waiting list for our chemical monitoring sites. Sometimes we really need volunteers. Check in with us and we'll see what's available. All right, so we'll move on to our biological action team. Our BAT volunteers, they monitor macroinvertebrate populations, and they do that in the spring, the summer, and the fall to capture those seasonal variations. But what is a macroinvertebrate? Well, a macroinvertebrate is a spineless aquatic organism, that's the invertebrate part, that are large enough to be seen with the human eye. That's the macro part. So if it was a microinvertebrate, then we would need a microscope in order to see that organism. So what is involved, like who is a macroinvertebrate when we're looking at a stream? Here, I'd like to focus just on one. This is the mayfly. And you can see now is the time really for mayflies to be hatching and really swarming around in their adult terrestrial form. And very soon, they will be going through this process right here. And the adult has wings, it flies. In the larval stage, it's aquatic. So it will sit on top of the water, release its eggs, and the eggs will almost immediately hatch into mayfly nymphs, which is the juvenile version of this organism. And that nymph, that's the macroinvertebrate that we're looking at. And I just want to mention, look at how quickly they go from the egg form into the nymphal form. That is a great adaptation when you're living in a stream where there's a lot of predators around. If you are an egg, you're sitting there, you are delicious lunch for someone. But to be able to really hatch into your nymph form as soon as possible makes you mobile and makes you able to really escape potential predators. And then here, we have what it looks like when those nymphs grow older. They will then crawl to the edge of the stream, maybe perch on a leaf, and they hatch out. And he will remove his body from his nymphal exoskeleton, let his wings dry and harden, and he'll fly away, and he's an adult mayfly. So it's only in that juvenile phase that we're really looking at these organisms as macroinvertebrates that are aquatic. The population of the macroinvertebrates is really what we're looking at. Which types of organisms are living there and what their pollution tolerance values are. So there's 3 general pollution tolerance values for the organisms that we find. Those that are in this green category, they're really pollution sensitive. If you find these organisms in your stream, you can kind of infer that there hasn't been a lot of pollutant inputs into your stream. On the other side of that, on the red side, we have really pollution tolerant organisms. So things like scuds and leeches, they can really survive anywhere under a variety of different really bad water quality conditions. So we don't not want to see a leech, but we want to see a leech right next to a mayfly. You get that diversity and also the combination of the pollution sensitive, the neutral, and the tolerant organisms. That's what we're really looking for to help determine biological stream health. So I am going to switch over. As I mentioned, I went this morning to Beeden Brook over on Aunt Molly Road. It's in the St. Michael's Farm Preserve. And I collected a few samples of macroinvertebrates. Now, if you hopped on the webinar a little bit early, you had a chance to take a peek at some of these critters. But let's see what we found. All right. So here, let's see if we can adjust the lighting. We have caddisfly larvae. There's a little bit of gunk in here. Try to separate that out. You can kind of see that their gills at the end of their body are moving, trying to get that oxygen. All right, so caddisflies, those are one of our pollution-sensitive organisms. That is a good sign. Here, we have a water penny beetle. Try to adjust this. This is another organism that is really sensitive to pollution. You find them in riffles hanging onto rocks. They kind of look like pennies. That's why we call them the water penny beetle. Here, we have a mayfly nymph. So this is from the example I just showed. This is the mayfly in its juvenile form. And you can see him hopping around a little bit as well. Who do we have here? Another mayfly. We have a variety of different mayflies in Beeden Brook today. That is a good sign. These are all pollution sensitive organisms. Now I'm going to flip this tray around. And here, what do we have here? We have the midge fly larva, and there's lots of these friends in the stream. These are actually very pollution tolerant, but the fact that they're there along with the mayflies, the water pennies, and the caddisflies, that's a really good sign. Then we're seeing the really high quality organisms, and we're seeing a diverse grouping of them as well.
Erin?
So, yes.
We had a request that you have to, in order to get the digital scope to full screen, you have to stop sharing your presentation for a moment. Yeah.
Is that better?
Yep, perfect.
Okay. Yeah, so again, these are the midge fly larvae. They are moving about, trying to move that water over their gills. And I will take you right back to the mayfly so you can see it in full screen. The mayfly has gills along the side of the abdomen and two or three tails at the end of the body. And this is a one we really, really like to see. This is a good one. Now the water penny, I think, is more difficult to see in this light. Maybe you can see that really the structure of the body is very similar to the mayfly. It has a head, it has 3 pairs of legs, it has gills along the abdomen. However, it has this enlarged exterior coating that kind of resembles a penny, which is a really great way for it to latch onto rocks and kind of blend into the rock, making it harder to attack by a predator. And then the full screen view of the caddisfly. You can see those 3 pairs of legs, kind of looks a little wormy. And these are interesting critters because they will actually create their own home that they can carry around with them. They will secrete this sticky silk substance that allows them to adhere rocks and debris to their body. which also is another way for them to blend into the rocks, making it more difficult for predators to come at them. Okay. I'm gonna hop back to the screen. But these are some really good examples of the kind of organisms that you could be handling, that you could be sampling if you were interested in joining the biological action team. So the first thing that our volunteers do is they go out with the D-net, waders, and they rub the rocks, they get down into the sediment, and that allows those organisms to come up into the net. Then we bring those organisms back to our lab where we will then sort them and then identify them. And this is kind of that procedure that includes both field work and lab work. So this is kind of a more intensive volunteer effort. And we just went through and identified some of our critters. Okay, are there any questions about the biological team before we move on? I think we're good. Okay. So our bacterial action team, these are a group of volunteers that go out every week during the swimming season, during the warmer months, from May to September. They collect grab samples, meaning they will just dip a clean bottle into the water to collect a sample, which they will then bring back to our lab where we will analyze it for E. coli levels. And E. coli, just a little primer on that, it's a bacteria that's commonly found in the digestive system of mammals. So this is something, it's a relatively easy type of bacteria that we're able to quantify. And it really tells us a lot about other potential pathogens that could be in the stream. And these are some of the major sources of bacterial contamination in freshwater and in our area as well, or our area anyway. We have dog waste, of course, so it's really important to pick up your dog waste. We have cracked sewer pipes that could be leaking directly into a water system. We have wildlife, geese, Canada geese. Boy, that's a lot of waste that's going directly into your potentially clean water system. And then livestock agriculture, letting the cows get directly into the stream, of course, is going to introduce a lot of waste into that stream. So there's best management practices that farmers can implement to kind of keep those cows out of the stream. Our bacteria volunteers, what do? They collect their samples, they go out, they use an aseptic technique. So in other words, they want to make sure that they're testing the bacteria of the sample water and not of their hands or anything. So you have to be really kind of sensitive the way that you collect your water sample. We then bring it back, they bring it to our lab where we will introduce some reagents into it that kind of feed the bacteria, allow them to grow, and then we incubate that sample for anywhere from 18 to 48 hours, at which point we will then quantify that bacteria. So here we have a quanti-tray, and this is also from Beadenbrook, taken a few days ago. I've prepared the sample, fed it, incubated it, and now I would love to show you how we actually count the bacteria levels. So I'm going to switch over to my cell phone. Bear with me. All right. I'm going to stop sharing here. There we go. Can you see this? This was the setup. We have our digital scope and our macroinvertebrates that I was showing earlier. But now I would like to show you our UV box.
Erin, we are not seeing your phone.
You're not?
No.
Oh no. Okay. Let's see. I think maybe wall.
Should I make your phone the host?
That's fine. I'll try to do it from here. Okay. So the way that you can see me here, right? We have our tray here. We put our water sample in and fed, incubated it. When the clear sample turns yellow, and you can see that we have some yellow spots here, we count the number of wells that have turned yellow to indicate the value for total coliform. Now, to get a little bit more specific, E. coli is a type of total coliform. And the way that this reagent works is that the well will be fluorescent if it's positive for E. coli. So I'm going to turn on our UV light and see if we can wave it over here. So can you see some of the wells here are fluorescing? That
Yep,
is,
we can see it.
that's a positive well for E. coli. And so that is how we actually will enumerate our E. coli values. It's kind of an easy test to do. There are 51 wells here, there are 50 small wells, and depending on the number of wells that test positive that either turn yellow for total coliform or become fluorescent for E. coli, that will give us the most probable value for the E. coli levels. Kind of interesting. All right, I'm gonna go back to sharing my screen. Are there any questions here in the meantime? How does the water quality in our area compare to other parts of the country? I'm going to pause on that one and I will address that in just a few minutes. Does the Watershed Institute have their own lab? I am in it right now, yes. Yes, we have our own lab. We have field equipment that we will take out into the field with us. We also have some equipment here that will allow us to enumerate things like nitrogen values and phosphorus values. We have our E. coli station that helps us to enumerate how much bacteria contamination is in the water. When we're looking at more complicated constituents, things like, earlier they asked about PFAS and hexavalent chromium. For those, we would take our samples out to an outside lab for analysis there. Okay, so what would the total value of this screen be? Great question. So this bacteria, the E. coli levels in here, I believe are about 600 colonies per 100 milliliters of water. The state standard is 235 colonies. So that's above the standard. Yeah. Maybe that it rained and that could have impacted the amount of E. coli flowing into the water. The Watershed Institute tests PFAS? No, we do not test PFAS. We take those types of samples out to exterior labs. We have the ability to test for nitrate, nitrite, phosphate, total phosphorus, chloride, iron, E. coli, total coliform, fecal coliform, dissolved oxygen, pH, conductivity, those kinds of things. But when you get into more complicated chemical compounds, then we move out to another lab. Do you monitor water levels and flows? Yes, our biological volunteers, when they're out there collecting their samples, they will also do a rapid habitat assessment as well, where they'll measure how fast the water is flowing, measure the width and the depth of the stream, and kind of do like a physical assessment of that stream. So we have another question. Do you see people that have been doing this for a long time switch between teams to keep it interesting, or do they tend to stay with the same activity? Excellent question. Well, I would say that a lot of people, most people, tend to stay within the same team. But of course, in any group of people, there are going to be overachievers. And we have some folks that work on all 3 teams, some work on 2 teams. You know, it's really, because there's such different requirements for volunteer commitment levels, there's really something for everybody. And, you know, we can kind of provide that opportunity for volunteers to get involved at whatever level that they are able to. Okay. So we are going to move on. This is kind of just what I was talking about. What are the commitments for a volunteer to be able to participate in these 3 different teams? With the chemical action team, they spend about 1 to 2 hours in the fields every month. There's a requirement for an annual refresher session where you kind of get tested to make sure that you know what you're doing in the field. That's one of those things that's written into the quality assurance project plan that DEP reviews. To get started, there's a full day of training to get to know all of the different tests that we do. And it's kind of an independent work. You really don't need to go out with a partner. You can kind of do it on your own. The biological action team, however, you really do need a partner to work with this. While you do spend that 1 to 2 hours in the field every 4 months, there's an additional 3 to 4 hours in the lab, processing and identifying those samples. There isn't a testing component here. You must pass an identification test. That is new, so if you're an existing biological volunteer, you'll be receiving more information about that soon. And then the training for this team is also quite a bit more intensive. There's 2 to 3 full days of training before you can really get started in the biological team. For the bacterial team, this one is a little bit easier. You're spending about an hour, maybe less in the field. You can choose to participate for 1 5-week period, or you can choose to participate for any number of 5-week increments up to 20 weeks during the summer. The most important thing here is that you have transportation. So you're going out, you're collecting grab samples at a number of different sites, and you're bringing it to the lab for analysis. The training, you know, it's really just how to collect a grab sample, how to do it without contaminating the sample. So it's pretty easy. Okay. So we have another poll. Steve, if you'd like to activate the second poll. And if you have any questions, hop those questions right into the Q&A box. And this is just my sneaky way of trying to figure out if you would like to join our program as a new volunteer. You can choose to join as a chemical volunteer. Again, that's monthly. Biological volunteers collecting macroinvertebrates every 4 months. And then the bacterial volunteers, which collect weekly. Obviously, these are unusual times. So things are kind of on pause at the moment, but this is a question that would certainly apply for, you know, when things start opening back up. So I'm going to hop into the QA. Okay, for bats, do you assign me a partner? If you're joining the biological team, you do need to work with someone else in the field. Sometimes volunteers will choose a friend to work with that they will go out in the field with. They kind of make it a fun little afternoon, you know. We certainly assign partners though. If you know, need someone to go out with you, it's a great way to meet a new friend. You know, you're going out in the field, spending some time in nature, and then working together in the lab. I've seen some very unusual couplings in the past, but they all tend to work out. So yes, we can, or you can. So do volunteers get to work in the lab? For the biological team, yes. You would come into the lab every 4 months to process your macroinvertebrate samples, like these here, what we were looking at through the scope earlier. For the bacterial team, if you're interested in processing your own bacteria samples using our IDEX system, certainly come talk to us about that, and we can work with you to get you trained up, and we could get you started on doing that kind of work in the lab. For the chemical team, the lab is the stream, and you are kind of creating your own lab out there in the field. Okay, let's see. What the public really wants to know is, can I eat a fish coming out of the stream with a reasonable confidence that I won't develop a bad illness? Can I get into the stream confident that my health won't be adversely affected? And can the public see those 2 points without getting bogged down with wonky science info? I get it, Louie. So I'm going to actually bring that up in just a second. Oh, wow, look at you. We have some folks interested in joining one or more of our teams. So we're able to collect that information on the back end, and we will be in touch with you to get you started and to get you into a training program. So to answer that question about the fish, can you eat a fish and be relatively confident that you will be safe? DEP does conduct fish tissue testing where they measure things like mercury contamination, and they will offer guidelines as to like how many fish you can eat per year or per month or per week of the particular species to make sure that you're not poisoning yourself. That is a very difficult question to answer, and it's one where we really don't have enough data. That's definitely a point, an area of growth for the future. We need to collect more fish tissue data, and we need to get it out there in a way that people can consume it. And I agree, sometimes it is a little bit difficult to process monitoring info and scientific information in like an easy way. But one of the ways that we try to do that is through our online mapping system, where we will display our StreamWatch data according to each parameter that we're testing. So this is an example. This is a map that includes data from 2018 and before. We're currently working on a new map that will hopefully make it even easier for you to be able to glean that information from the data. But you can see it just kind of has the color coding system, a grade from A to F. It gives you the general idea of the health of the water. Now, this is a look at the new system. Again, this is in development now, but we're hoping that by offering like the charts where you can actually track, over time how the data has been changing, and you can again see those color-coded sub-watersheds, then you can learn more about your watershed and stream health in your area. Another way that we do that is through our sub-watershed report cards that we publish in our quarterly newsletter, the Wellspring. And again, we just have the color-coded dots for each parameter, and that will give you kind of an indication of the general health of the stream. Now, if you're concerned about your own health getting into a stream, I would pay particular attention to that bacteria line. That's really, the number one thing that's going to impact you as a person swimming or boating in a stream. Making sure that bacteria level is on the lower side is really going to benefit you so you don't get sick. We also do issue-specific analysis. So this is kind of taking it up the chain a little bit to municipal, government, local decision makers. So for example, we had in Cruiser Brook turbidity levels that were off the charts. You can see that orange line, that orange horizontal line, that's the maximum 30-day average. The horizontal gray line is showing you the point at which the turbidity level should never go above that. Turbidity is kind of a measurement of how cloudy the water is. It can tell you how much sediment is getting into that water. So the water was pretty much milky. And you can see in the values collected by one of our volunteers that we definitely had some spikes in turbidity. And so one of the ways, you know, that we're trying to address issues like this is getting it out into local media, sharing this information with you know, the municipal officials within that town, and trying to address the actual contamination that's coming into that stream through either green infrastructure or regulation. You know, any way that we can really prevent streams from being contaminated, we are working on it. And the science really helps us to make those decisions. And as I mentioned before, this we also use our data at DEP for our state regulation. The Integrated Water Quality Assessment Report. It's a very long document. It's one of those wonky scientific documents that gives you tons of information about water quality and stream health. And StreamWatch data is accepted into this report, used for regulatory decision making and to protect streams that have been, you know, measured at really pristine levels to prevent any development from happening in those areas, and then also to help clean up streams that are contaminated, that are polluted. But looking at how our streams compare to the rest of the state, we still have work to do. This graph is from the integrated report, and this is an indication of the aquatic life use, so that general biological health. The red spots are sub-watersheds where biological health is not at a high enough quality to support a healthy ecosystem. So in our region here in central New Jersey, we do have a lot of red, just like the rest of the state. We have some green, we have some yellow, which means we have insufficient data, and those are priority spots for us to expand our monitoring into those regions. So in order to do that, we need your help. And we have our contact information on the left-hand side. I'm Erin Stratz, that's my email. Please feel free to email me if you have any questions, or you can ask them here. Steve Torto, he was our moderator today. His information is also there. And then Nick Hansen, who is our StreamWatch program coordinator, I've also included his information. So I invite you to look at the website. You'll find tons more information on the StreamWatch program. You can check out those maps with actual stream health information. And then, of course, I would invite you to become a member of the Watershed Institute and become a volunteer. So thank you. I will check the Q&A box. Where do I find the water quality maps? If you go to the watershed.org/streamwatch, you can click View My Report Card, and you'll be able to see all of that information there. And this webinar is being recorded, and it will be shared after it's through. We'll send you an email with the link so you can share it with friends or watch it again if you would like. Okay, Steve, were there any other questions that I missed?
Erin, there's one more question that was asking if it was safe to swim in certain local waters.
Ah, okay. That's a tough question to answer. There are some water bodies that we monitor more often than others. One of those being Petty Lake in Hightstown. So there's a group of folks that put together the Hightstown Triathlon every September, and they host weekly practice swims up to that point just to get used to swimming in the lake. And so for that, just to protect the health of those people who are getting in that same water week after week, we do have a weekly monitoring program where we're checking and we're reporting that information back to the triathlon staff as soon as possible to kind of give them a yay or nay should they swim that week. So Hightstown and Petty Lake, it's definitely a swimming hole in that area. For other lakes, for other rivers, it's harder to say. I guess I would need a specific water body that you'd want to get in. I go swimming in Lake Carnegie, you know. We monitor there. But generally, I think it's good protocol to not go swimming in a water body within 72 hours or 3 days of a heavy rainfall, because that's really when a lot of that bacteria is washing into the water, and that's what's really gonna hurt you if you're swimming in that water.
And Erin, we had one more relevant question, which was, do you have any idea when training might start again?
No. We will start training as soon as we're able to leave the house, you know. So that's a tough question. But again, we'll harvest your emails if you responded to that quiz earlier on. If you're interested in getting started, we will certainly contact you and let you know as soon as those trainings start back up. And we want to start it up just as much as you guys want.
There's one last good question, Erin, and that is there a fee for training?
No, there's no fee. You are doing us a service as a volunteer. You are helping us to collect data on our behalf. I'm one person. I can't get out to 40 different sites every month to collect this really valuable information. So really, you know, the fee is your time, is your commitment, is your attention to detail and wanting to get the testing right and to do it in a way that's really producing high quality data. And we do ask just for a 1 year minimum commitment, because the training is sort of intense. So we want to make it worth your while to participate. Okay, well, if there's no other questions, I just want to thank you again for joining me today in the lab. And I really hope to hear from you all soon. Stay safe, stay healthy.